Well, hello, folks. Top Gun here with you, and I got a strange one for you. That's right, I am not going to talk crypto. Zero, zilch, zip. I'm bored, I got an afternoon off, and I'd like to discuss something that's been on my mind for a while. Who knows? Maybe I'll get a whole different audience. You guys can just click and go away now. And hey, if you're new to the channel and you're checking this out, if you're interested about my thoughts on this, you might be interested in my thoughts on other things. So let's try this out. What did you click on? Warp drive? What? Is this Star Trek? Who's this Albuquerque White thing? Oh, why? What? What's going on here? Okay, yeah, I'm going to talk to you for a moment about warp drive. Hello, Trekkies, James, Tiberius Kirk fans. Yes, Christopher Pike was the true captain. We love the spin-off. Sure, let's nerd out. Let's nerd out. And, may the Force be with you. I can go Star Wars completely as well. Not just isolating here. I love the crossover memes. They drive me up the wall and make me laugh at the same time. So, the Albuquerque White Drive. To give you a little bit of a backstory on this, I've been tracking this for a while because I'm a hobbyist when it comes to quantum physics. I really love this stuff. Schrödinger's cat, the actual superposition theory and quantum entanglement, actually looking at the baseline mechanics that Schrödinger put out using lambda to calculate wavefront probability, whatever. I'm trying to make this simple, so I'm not gonna, okay. So, staying simple here. Some nerd, theoretical physicist, I think Dr. Albuquerque, is working on actually making a warp drive. Star Trek, it's cool. Let's see, how would we bend space, So, okay, a warp in a cell, a big metal tube with copper around it that makes a magnetic field, and you actually make it a vacuum inside. Completely vacuum. Okay, that's how you design the thing, and you put whatever frequency through the magnetic tube, and kind of shatters space and time a little bit, creates exotic particles. So in my mind, it's like it almost creates a string through a filament through there, where it allows exotic particles, which means from another dimension, another space, kind of. They're not normal for this space and time that we are in. When the exotic particles are created, they create gravity, in a sense, and they allow us to distort or contract space, to shrink it. Talk about the shortest distance between 2 points is always a straight line. Well, I love the movie Event Horizon. It explains it very simply when it puts the hole on this side of the paper and this hole, the straight line would go the whole way across. Well, you fold it. You actually bend space somehow and bring the 2 points closer together. 0 is the shortest distance between 2 points. Now, this drive's not crazy enough to do that, but it warps space a little bit. That helps. And how much can you warp it? That's where the science, the interest is. So this theory is all great and whatnot, but it takes something, the energy source that they need, the fuel source. I assume they're talking about a radioactive mass, a dense metal like plutonium, but the mass would be the size of Jupiter, I believe it was. And we know that in the storm center, 3 Earths sit in there. That gives you some proportion or ratios that's not going to be practical to shuttle people around it. Can't do it, useless. However, as of my understanding, apparently some of the story has changed, or I might have this wrong, but I'm going to go off my memory because I was tracking this. Basically, another, more of an engineer, scientist. They have different fields. This one's not theoretical, more practical engineering. Anyway, he works as a consultant for NASA, Dr. White. Dr. White gets a hold of Albuquerque's findings, if I haven't mixed their names up. I'm bad with names. Once he does, well, he's putting together for NASA a proposal, all the future technologies, what it would cost to build them, and he's looking at the math going, this is great, but, you only got one ring on here, one coil. It's kind of like front-wheel drive. He thinks about it practically. What about four-wheel drive? What if we put 2 nacelles on there, 2 rings? What happens? Energy requirements shrink from the size of Jupiter to roughly, I think, about the size of planet Earth. That's interesting. That's a lot of mass reduction. Still, something the size of our planet, lugging that around as a power source for your little itty bitty ship, not practical. but that's one heck of a jump. So he plays with it a little more. What else can I do to it? Okay, this should have no bearing on it whatsoever, but the shape of an airplane, the way it distorts air, it cuts over, and, that shape. These are just rings right now. What if you shaped it like like they're donuts, actually, but what if you shaped it more like a ring, curved it like an airplane ring? That shouldn't do anything at all. But running through AutoCAD, let's see what it does, and wouldn't you know it, it drops the energy requirements down to the size of the moon. Well, that's still pretty big, but we're making a crap ton of progress here, just changing around the design of the machine that would run this theoretical math. So finally, one more thought, that bending space like this, you're kind of like cutting through water, like a big oil tanker, just the bow cutting through the wake of the water, pushing it. That takes a lot of energy, right? But a skidoo, that just jumps over the waves. A puppity-puppity-pop. Alright, that takes a lot less energy to go to the speed, so this thing's using direct current. I figured out alternating current quite a while ago. What if you use that? Have the same electrons go back and forth instead of just pumping more and more. And, whoa, wouldn't you know it, suddenly the energy requirements shrink to something about the size of a Buick. A Buick, you say? I mean, a nuclear reactor is larger than a Buick generally, so like a nuclear reactor in space is still kind of large, but suddenly we're getting to practical ideas. Holy crap, that means they can produce enough energy in a city. That means they can test this thing on tabletops and see if it really works. Skipping to 2013 to 2015, that's exactly what they started doing. And the different tests they did all seemed to indicate that light traveled faster than light, because it got to its destination sooner. But that's impossible. There is a cosmic speed limit on light. There is, and I'll get to that later in my complaints. So what it did was just shorten the distance between the 2 points. It actually brought them closer together across the top of that table. Creepy, right? So this technology excites me, but there's issues with making it stable, making it last. Like, this is still not practical. It's just, wow, there's the baseline. This is like playing around with a mason jar and some acid and 2 metals to make your first battery. That's nothing compared to a lithium-ion battery inside your cell phone. So it's the baby part of the technology, but it's there. Wow, cool. As a nerd, I'm just loving this. Loving it. And the wavefront field it produces, the way they express the contraction, it's cool to look at, but maybe I'll actually Google that for us. Yeah? Yeah, let's look at this. Okay. Kirky. White. Warp. Drive. This should correct my spelling. There it is. Images. So this is the theoretical ship, the 2 rings that I'm talking about, and here's the distortion field it creates. So now we've got some images while I'm talking about it. Yes, this is a thing. I'm such a nerd. Okay, so now we fast forward to now, and there's some practical issues with it. Although they found some more technology, nanofilament stuff that I'm not going to bore you with, makes it more practical and easier to use. But it's still, they're getting to the point where they're going to launch something about the size of a red Solo cup into space, and that's going to be the first practice vessel, because of the new nuclear reactors that are a bunch of little buckyballs that are about the size of a tennis ball. Isn't that cool? The size of a Buick got even smaller. So they're going to be able to test this crap, just in the small things, but on a long burn frame going close to the speed of light to try and say get to Alpha Centauri, the field destabilizes with Hawking radiation. And there's another issue where traveling through space that quickly, kind of by condensing it, you collect a lot of particles you shouldn't. There's a lot of ambient radiation in space, so you kind of create a death bubble in front of the ship. So whatever you're flying towards, when you stop, that radiation keeps going, and you basically death ray annihilate. So if you're flying at something, you better fly just off to the side of it. Make sure your ship's aimed at some empty void of space for the radiation to dissipate in that direction. So as you slow down, it can fire off in a safe way instead of what you're flying at. But not that issue, debatable to how you're going to handle it. The worst part is the Hawking radiation. Oh, Hawking in your quantums, and you're really getting in the jive of time relativity with Einstein, but Hawking radiation, thanks to quantum entanglement superposition, appears to destabilize this. Now, it's because there are technically small destabilizations in what you'd call like inconsistencies in quantum mechanics and temporal mechanics. They have a hard time figuring their way out, and that could be producing the Hawking radiation. But the way this was described on this video, I did not like. Now, there was a commenter who went right into the science and corrected it. I'm like, good, I don't have to tear them apart, but it's been on my mind. And I'm like, I just feel like talking about it. So what the guy did was he used the Minkowski space-time diagram to illustrate some points about why it might produce Hawking radiation to stabilize. But this was wrong, and I want to test you guys and see what you think. So let's show you what a Minkowski space-time diagram looks like, instead of me drawing it. There, Minkowski space-time diagram. So there's complicated 3D, but this triangle here, this one's good basic. So you imagine any given point in time and space, you are at the center of this diagram. That is where you always exist. You are here, point 0, 0. You know, on a mall map, this is where you are. So the bottom of the triangle behind you, that's in the past. That's anywhere you could have been in the past, because there's only a certain amount of space you can travel in a certain amount of time, which dictates the angle of the hourglass, and the same is true going forward in time. Now, because the speed of light moves in light years, it's funny, the up and down, if you track it in years, the side to side is tracked in light years. That means the speed of light is always on a 45-degree angle. It will always travel 1 year, or 1 light year in space for every 1 year of time. So it must be a 45-degree angle. You cut the math right out of it with this drawing. So the 45-degree angle, the x over here on this one, is basically the speed of light. Oh, I think we've got the CT for the speed of light. Oh. Okay, so now there's some more confusing elements of how this works. So the idea with this diagram, if we go back to this one, here we've got the speed of light. So with this diagram, if you imagine another line up and down, straight side to side with this line, you imagine this line is Earth, and 4 light years over here is Alpha Centauri. And then whatever distance back here, let's just imagine there was another solar system, 4 light years the other direction. And it has to travel 8 light years to get to Alpha Centauri and 4 to Earth. We're in a straight line, so this is easier to work. Now, basically, if, say, that sun exploded, well, basically, we're here at this point in time. Alpha Centauri is here at this point in time. So if it explodes here, we don't find out about it for 4 years, and Alpha Centauri doesn't find out about it for 8. Okay, so this is a relation of time and space. Now, the funny thing about going faster, going towards the speed of light, theoretically light, as it's going, even though it has a speed limit, like a cosmic speed limit, it's basically entangled with time, so that for light, it exists in one moment only. All of space and time along its path is happening all at once for it. That is how time is distorted. You can't go faster than the speed of light. Okay. So, but as you approach the speed of light, so say you've got an angle coming up very close to this line, this timeline bends, and you measure it on an angle just below the speed of light equally. So maybe I should start drawing this stuff out. Yeah, because it'll get really complicated if I don't. So, File, New. Okay. Alright. Okay, this should be about 45. We're just going to draw this a little willy-nilly, folks. Okay. Okay. Alright, and our theoretical thing that stops existing back in this point of time. Okay, now, the way he relates this is what bugged me here. So if you're traveling, and let's go ahead and make that a different color. Okay, then the timeline, the one below, will have to go on, say, this angle. Okay, so what did that mean for him? How did he see that? Well, let's make blue. Okay. Now let's make another color one. How did he see that? So make it an intersecting one. So on the same angle as the blue one. Okay. So here we go. Now, there. So this is how he makes the time slice. So basically, while the ship is moving through time, through space, that red line, this is how time goes for them, where time is normally on the normal side-to-side axis. So what this actually means is that for basically the 4 light years it travels, it takes it almost 5 years to get there. So for the 5 years, what we can see on Earth, like if we're going up and down, but we readjust that line to go 90 from the bottom line. But basically, we only exist for a year and a half. We experience going at that speed much less time. But now, because of this line, the way he inferred it was that the ship could somehow access a point in time earlier because of where this yellow line, see how it intersects that first one that stops, that first line. He inferenced that now this point in time down there was connected with up here on the last line where all our blue and red is. Like, see how it connects across like the speed of light connects? So he's reading time like this, like somehow these points of space are now connected to this ship through this time, and that is the fallacy of the diagram. This does not extend from the ship outward to other things. Okay, so we can delete this. Alright, all this is meant to do is express, and we'll draw the line in, so now that this line goes on here from a 90-degree angle, this goes up. So as space, as the ship travels along to get to here, alright, we're seeing that this is the block of time that exists for that ship relative to the time that happens for everyone else. So Alpha Centauri experiences 5 years. Earth experiences 5 years. But that looks like maybe 2 years or a year and a half. I'm not going to measure it to do the math. But that's what they experience. And why does that happen? Well, entropy, this is my theory, correct me if I'm wrong, but entropy is the state of change of particles. So at absolute zero, nothing happens. Time is frozen. Things can't change state. But electrons moving this causes a state of change between molecules. This is entropy. This is what happens through time, changing state, the experience that we feel it. But if we're already moving at the speed of light, remember I said the speed of light is a cosmic time barrier. If we're already moving at the speed of light or close to it, the electrons inside of the matter that's traveling, well, so an interesting thing, if you're in a car and you're going 100 miles an hour, and you got a really good tennis player that can throw a ball at 100 miles an hour, and he throws that ball while riding in the car, technically that ball at launch is going 200 miles an hour. That makes sense, right? Car plus throw equal more. Well, if you're going near the speed of light and you turn on a flashlight pointed forward, funny enough, you're traveling pretty close to that light. It can't go any faster. It doesn't add. There's a limit. Well, electrons move at the speed of light. E equals mc squared. C, speed of light, in the mass. Mass times light equals the energy. Electrons. So there's a speed limit on all of it. And if you're already going close to that speed limit, there's not much room for the electron to move. If there's not much room for it to move, it can't change state very fast. The faster you move, the slower time exists for you, not connecting you to other points of time. That's all. If the ship is, say, let's keep that yellow, click off, but let's get a dot here I need a dot, folks. So green. So let's say the ship is here. Okay? You are still connected to this point here and this point here. It has only been a year for you. It's been 3 years in these places. But this does not connect you this way to this point in time back here, or an earlier point in time in Earth while you're here. You're still connected to these. And that's what causes the distortion. Not that things happen out of order, but if quantum entanglement exists, when something happens here to a quantum, the reaction is instantaneous here. So things have to happen at the same time, even across spooky action at a distance. Sorry, spitting that out sometimes. I love that one, spooky action at a distance. Man, he had a way worth with words. So, because of that, well, if here is moving faster and freer, because it's not governed by a time distortion, but this is time distorted, that quantum entanglement now has an issue. That's the inconsistency in the temporal mechanics, where maybe that's what's producing the Hawking radiation. And I mean, quantum entanglement, in interesting ways, again, put it in a box and don't look. The observer principle is really important in superpositions. So there may be some element to shielding Hawking radiation in that, and an answer in that, but I really don't like if people inaccurately describe where the issues are. Like, the simple mechanics can be dumbed down in a way that people can understand, and then you can build upon that. So, simple mechanically, going near the speed of light does not connect you with earlier points of time in space or later points of time in space for where you're going or where you've been. It's not how that works. It just, in relation to the time around you, less has happened because there's less room to experience it, which does mess with quantum entanglement. Okay? So, you know, we got some crap between Einstein and Stephen Hawking going on here, but this is, you know, if you're going to use Minkowski time-space diagram, I love it. If you're going to talk about this stuff, I love it, but please try to critically think about it properly. Going fast near the speed of light does not reorder the sequence of events that you experience. It's not how it works. Now, if you get over that line, if you go faster than the speed of light, that argument changes. And yes, the distortion of experience between relation and time and effect, and that's where, you've got major issues, and the space diagram can be used for that. But just traveling near the speed of light just causes some tension and friction and quantum entanglement, from my opinion. That's how I see it as a hobby quantum physicist. If I've got it wrong, feel free to comment. I love to learn. And if my rambling on all of this subject matter has piqued your interest, maybe you want to check out the other stuff that I find interesting. With that, thanks for tuning in, folks. And if you're my regular audience and you sat through this, well, man, I am so proud of you. I might even give you guys a gold star. Like, leave a comment and you can request any content you want. I can even do a twerk it video like Richard Hart, okay? You sat all the way through my passionate love of quantum physics for a moment for a rant. So if you want, you can, you can request whatever. Maybe I'll buy watches, you know, like, whatever. Not trying to be him. I'm just saying whatever tickles your fancy will make you happy. I'm not going to light myself on fire. Actually, I thought about doing that once. I used to do some stunt stuff too. I thought about lighting myself on fire to explain how to stay calm when PulseNet launches. If you really want to see that one, you want to see how crazy I am, don't do this at home, folks, and I'm not a financial advisor. However, I probably am a mad scientist, and it's a good thing I've never had access to a lab. But if I do get rich, I know what I might buy. I finally figured out what I might do with my money other than just fix my car. Yeah. Also, maybe I'll talk about antimatter the next time. It's not actually required for warp reaction, but it is an interesting store of energy. 4 pounds of it hit the Earth. Well, no, 4 pounds of light hit the Earth a day, but about 8 pounds or something. There is a few pounds of antimatter that hits the Earth a day. It's actually a naturally occurring kind of substance, but there's only like 10% of it to the ratio of the rest of the matter in space. Whatever. It's a whole nother video and a whole nother conversation looking at the 6 different aspects of technology that it takes to hold antimatter together for almost 30 seconds in our reality. I love my sci-fi. So, and my science, actually. Hobbies are fun, folks. It's better than going to the bar. So anyway, thanks for tuning in. Until next time, hit that like and subscribe if you find this interesting. And yeah, let me know what content you want to see. Because apparently I've got a little time off work. It's not great for me. Pulse hasn't launched yet. So, yeah, thanks for being here. Hope you enjoyed. Take care.